We can now convert between the molar quantities of different substances involved in a chemical reaction, and even find the number of molecules these quantities represent. But neither of these are the most practical values to calculate. The most practical value to know will be the grams of various substances involved, because that is the easiest value for human beings to measure when it comes to examining matter. We can't go to the stockroom in the laboratory and ask for a trillion molecules of something, but we certainly can weigh out 10 grams of a substance in order to perform a reaction. So we will need to be able to relate the masses of the reactants and products in a chemical reaction. When we do calculations like this, we will always convert a given mass into moles for that substance, then use the stoichiometric factor to convert to moles of the other substance, then convert back to mass for that other substance. So we can expect to use 3 separate conversion factors. Let's look at an example. Magnesium hydroxide, or milk of magnesia, is produced by the following reaction. If we wanted to produce 16 grams of milk of magnesia, how many grams of sodium hydroxide will we need? Let's set up our conversion factors. From the desired 16 grams of product, we can use the molar mass of magnesium hydroxide to convert this into moles. Next, we use the stoichiometric factor, in this case the 2-to-1 ratio from the balanced chemical equation, to convert this number into the moles of sodium hydroxide required to generate the desired number of moles of product. And once we have the moles of sodium hydroxide, we can use the molar mass of sodium hydroxide to convert to a mass of sodium hydroxide. Notice how all the units cancel precisely as desired because of the way we set up our conversion factors. Always check and make sure this is the case, because if the units don't end up the way you want them, you must have set these up incorrectly. Doing the math, we should get 22 grams of sodium hydroxide. This is useful information because now we know exactly what mass of the reactant we need to get the desired mass of product from this reaction. Let's try one more for practice. According to this reaction, what mass of gallium oxide can be produced from 29 grams of gallium metal? Again, let's convert our mass into moles of reactant, then use the 2-to-4 ratio from the balanced chemical equation to convert to moles of product, then use the molar mass of the product to convert into the mass of product. 39 grams is what we should get. And now we can perform a variety of stoichiometric calculations.